Okay, today we are going to learn about third parts of the probability lesson. First in the previous lessons we learned about sample space. Sample space means all the possible outcomes in an experiment. All the possible outcomes in an experiment we call as the sample space. When we tossing a coin, then the sample space is obtaining head or obtaining tail. Now this sample space we can represent the sample space we represent using, first we represent by listing. When we take the sample space of tossing a coin, we can list out like obtaining head and obtaining tail. We can listing the sample space. We can list in the sample space. Today we are going to represent in another way using two-dimensional grid, and also we can represent the sample space using a tree diagram and also using a Venn diagram. In a previous lesson we represent these types of event using Venn diagrams, and we list them. Today we are going to represent the sample space using a two-dimensional grid. Listing means in random experiment tossing a coin, we can write it like this: S equal inside the curly brackets head comma tail. Now we are going to represent in two-dimensional grid. Then now we are going to tossing two coins. We are going to toss two coins. Then outcomes are two heads or head and tail. From the first coin we obtain tail, and from the second head or from the both coin we get tails. These are the all the outcomes when we toss two coins. So yesterday we learned about when we are tossing only one coin. Now we are going to toss two events are there, two coins. Then these are the possible outcomes. Then we can write the sample space equal inside the curly bracket. First outcome is getting head in both coins. Second outcome is getting head in the first one, tail in the second one. Next one, from the first coin we get tail, second coin we get head. Next one, last one, from both coins we get tails. Now we are going to represent this using a grid. In a grid, now this is first coin. In the first coin's outcomes are head or tail. From this axis we represent second coin. Then from the second coin also outcomes are head or tail. Same as the Cartesian plane, we can mark the events here. That is events. Head means this one. Obtaining head from both coins. Next one, okay, this is the event of obtaining head from first coin and obtaining tail from the second coin. Then we can mark the events of obtaining tail from the first coin and head from the second coin like this. And this is the event of obtaining tail from the both coins. Obtaining tail from the both coins. Now here we are tossed two coins, two experiments. So if there is two experiments, we can list out the elements like this. Inside the curly brackets, we can separate the outcomes using brackets, or we can represent it using two-dimensional grid. Okay. This is the two-dimensional grid. Okay, let's find the answers to this one. Now, Putha, how many events are there? How many events? NS, number of elements in the sample space. How many events in the sample space?
4.
4 events. Now there are 4 events. Therefore, N is number of elements in the sample space equal 4. Now, the probability that both coins shows head. What is the probability of both coins shows head? Both coins shows head means only one event, this one. In here, first coin we get head, second also head. Then how many events are there? The probability that both coins shows head, only one event out of 4. Then we can write the probability as 1 by 4. Next one, the probability that coin A shows head and coin B shows tail. Coin A shows head and coin B shows tail. How many events are there? Coin A means first coin and second one. The probability that first coin shows head and the second one shows tail. What is the probability? From the first, yes? What is the probability? How many events are there? First coin shows head, second coin tail. Here also only one event. We represent here first coin head, second one tail. Then it also 1 by 4. Probability is 1 by 4. Next one, the probability that one coin, not the first coin, one coin shows tail and other coin shows head. How many events are there? So what is the probability? One coin, not the first one. One coin shows tail, anyone from these two.
2.
2 events. Very good. Now in this one, when we take this one here, from the first coin we get tail, second coin we get head. And here also, from the first coin we get head, second coin we get tail. Then from the one coin shows tail and next second coin shows head. Then there are 2 outcomes, such outcomes. Therefore, 2 out of 4 means probability we can write as 2 by 4. Now this fraction we can write in the simplest form. This one is equal half. Next one, the probability that both coins shows tail. Both coins shows tail, here it has only one outcome. Now both coins shows tail. So therefore probability we can write as 1 by 4. This probability we can write as 1 by 4. Putha, did you write the notes? This one. Okay, now we are going to represent 2 experiments in a 2-dimensional grid, tossing a coin and rolling a die. Nice. Then when we tossed a coin, okay, first let's list out the elements. Let's write the sample space. What are the outcomes? Tossing a coin and rolling a die. When we tossed a coin, outcomes are getting head or tail. When rolling a die, outcomes are 1, 2, 3, 4, 5, 6. Now we are going to do this to both experiments. Then what will be the outcomes? From the coin we get head and from the dice we get number 1 is 1 outcomes. Or From the coin we get head, and from the dice we get 2. Another outcome is getting head and number 3 in the die. Next one, getting head or number 4 in the die. Next, getting head and number 5 in the dice. Next, getting head and number 6 is another outcomes. Or from the coin we obtain tail. When we toss the coin we obtain tail, and from the dice we get 1. Or tail and number 2. Next one, tail and number 3. Next, tail and number 4. Next, tail and number 5. Obtaining tail and number 6. These are all the possible outcomes when we tossed a coin and rolling a die. Now here we did 2 experiments. Okay. Now like this we can represent it in using 2-dimensional grid. In the x-axis, this horizontal one represents the outcomes of rolling a die, and this vertical one represents the outcomes of tossing a coin. Now this event represents obtaining 1 from the die and head from the coin. And this one represents obtaining number 3 from the die and tail from the coin. Let's write first one, probability of obtaining tail. What is NS here? How many elements are there in NS?
Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. NS equal 12. Now what the probability of obtaining tail? Probability of obtaining tail. How many events are there?
6/12.
Yes. Now here, now this one represents probability of obtaining tail. First one. Probability of obtaining tail here. First and tail. This one. Number 2 from the dice and tail. Then there are 6. 6/12 means in the simplest form we can write as half. Let's see the next one. Probability of obtaining number 3.
Two/12.
It's 2/12. Here this one represents probability of obtaining number 3. Number 3 and head from the coin, or number 3 and tail from the coin. Only 2 events. Probability of obtaining 3. Then we can write the probability as 2/12 equal 1/6. Next one. Probability of obtaining head and number 6. Head and number 6.
1/12.
Head from the coin and 6 from the die. Here there is only one event. Head from the coin and 6 from the dice. There is only one event. Then probability one can write 1 out of 1/12. 1/12. Correct this one as O. 2 on the dice or head on the coin. And means here we talk about the intersection. 2 on the dice or H on the coin. How many events are there? 2 on the dice or head on the
8/12.
Okay, 2 on the dice means these 2 events. Now 2 on the dice means this event. 2 on the die or getting head. In these events we get head. Head. Then 2 on the dice or head means union of this set. Then 1, 2, 3, 4, 5, 6, 7. How many events are there?
7.
7. Only 7. 2 or getting head. Union. Then in the union there is only 7 units. We are not going to repeat the same one. Then 7 by 12. We can represent it as 7 by 12. Okay, now we are going to toss 2 fair dice numbered from 1 to 6. 2 fair dice numbers from 1 to 6. First we have to show the sample space in a grid. No need to list out. So we are going to represent the sample space on a grid. Now here we can represent the first one. From this horizontal axis we can represent the first die. And vertical one, second die. Then we can mark all the events. Getting 1 from both coins. Here, getting number 1 from the first coin, 2 from the second dice. Now this one represent number 1 from the first dice, 3 from the second one. So what is this one? What is this outcome? From this point represent obtaining
Getting 3 from the first die, 4 from the second die.
second one. Okay, now here we mark all the outcomes. Okay, try to find the answers for these 4 questions. Okay, first one. The sum of the two numbers being 5. The sum of the two numbers being 5. Okay, let's see. Sum must be equal to 5. Okay. In this event, obtaining 1 from both coins. Therefore, 1 plus 1, 2. Now, 1 and 2, 3. 1 plus 3, 4. 1 plus 4, 5. The sum of the two numbers being 5. Now 6. Next one 7. Here 2 plus 1, 3. 2 plus 2, 4. 2 plus 3 again we get 5. Now 2 plus 4, 6. Okay, in the next line 3 plus 1, 4. 3 plus 2, 5. Next 3 plus 3, 6. 7, 8, 9. Next one 4 plus 1. Now from these 4 events, sum of these events are in these 4 events, sum of the two numbers is 5. Sum of the two numbers is 5. Then what is the probability? How many events are there? N is
36.
36. Out of 36, how many events are there? Sum of two numbers being 5.
4.
4. 4 by 36 means simplest form?
1 over 9.
1 over 9. Okay, find the answers to next one. Sum of the two numbers being greater than 10. Greater than 10. Sum must be greater than 10. Greater than 10. Okay, here 2 sum is equal to 2. In this outcome, sum 2 plus 1, 3. 4, 5, 6, 7. So when we take this one, 3, 4, 5, 6, 7, 8. Next, 4, 5, 6, 7, 8, 9. Next, 5, 6, 7, 8, 9, 10. Greater than 10. Therefore, we can't get this one. Next one, 6, 7, 8. 5 plus 4, 9. 5 plus 5, 10. Okay, now this event. 5 plus 6, 11. Great, sum is greater than 10. Then 6 plus 5, 6 plus 6. Okay, in these three events. Only in these three events, sum is greater than 10. Sum is greater than 10. Therefore, what is the probability of the two numbers being greater than 10?
3 on 36.
3 over of 36 means 1
1
over.
over 12.
Next one, the two numbers being the same. How many events are there? What is the probability?
6 over 36.
Now, two numbers being the same means 1, 1, 2, 2, 3, 3 from the 4 from the both coins, 5 from the both coins, or 6 from the both coins. Now, this is the probability. Then there are 6 events, 6 such events. Therefore, two numbers being the 6 over 36 in the simplest form,
1 over 6.
1 over 6. Getting 3 on the first dice. How many events are there?
6.
6. Getting 3 on the first dice. Getting 3 on this first dice means in this line. Then it is also 6 over 36 means 1 over 6. Yeah, in sometimes you ask to encircle the areas. Encircle the areas means you have to draw around this point like this. You have to encircle all the points. Okay, next one. Okay, find the answers to this one. 4 buttons of same shape and size are in a box. One of them is blue and 3 are red. In these types of experiments, we write the sample space as only one blue. Then we can write B1. 3 reds. We can represent the 3 red buttons using R1, R2 and R3. One button is randomly taken from the box. And putting it back means in the second event also there is 4 buttons. Show the relevant sample space in the grid. So we can mark the sample space as like this. Next one, find the probability of the buttons taken out being the two different colors. Two different colors. Find the probability of the buttons taken out being two different colors. What is the probability? Two different colors.
6/16.
Okay, let's see. In the first one, both buttons are blue. Then next one, first one blue, second one red. Different colors. First one blue, second one red. Different. Here, first one blue, second one red. Different. Here also, first one red, second one blue. But in other three events, both buttons are red. In here also, first one red, second one blue. Other three, all the buttons, both buttons are red. Here also blue and red only. So we can encircle it like this. Encircle the area. Then this is question number 2. Then there are 6 events out of how many events are there? NS
16.
16. Then simplest form 3/8. Find the probability of the event in second one above when the buttons taken first is and without putting the box it into the box again. Without putting it into the box again. Without putting means now in the first one, if we take the first button, in the second times there is not, now this button is not in the box. So B1 event is not an outcome of this experiment. R1 also not outcome because the button is without putting into the box. Therefore, R1 is also not an experiment because we are not going to put the first button again. So in the second experiment, this R1 is not in the box. So probability means except these 4, then 6/, except these 4 means 6/12. 6/12. Okay, this question is from grade 11. Now take out your textbooks. Exercise 30.3, third question. Write the answers to third question. Exercise 30.3, third question. Try to find the answers to third question. A bag contains identical beads. There are 3 red beads and 1 blue beads and 2 yellow beads. These are named R1, R2, R3, B, Y1, Y2. A bead is taken randomly. Its color is recorded and then put back in the bag. A bead is randomly taken from the bag again and its color is recorded. Show the sample space in the grid. Then use it to find the probabilities of the following events. Okay. Now we can represent it on a grid. Okay. Now what are the colors of the beads? Now 3 red. 3 red, then we can represent it like Can you see the board now?
Yes.
3 red we can mark as R1, R2, R3, and 1 blue, then 3 yellow, Y1, Y2. Now this is the first step. First attempt. Then the second one, we can here mark as R1, R2, R3, blue, first yellow beads, second yellow beads. Okay, now we are going to mark the samples outcomes. These are the outcomes. Or you can draw a cross. Okay, these are the outcomes. Okay, now read the first question. What is the first question? First question. Textbook first one.
The first bead being red and the second bead being yellow.
First one is red. First taken, first one is here red.
Red.
In these 3 lines, first one is red. Now second one is yellow. Then first one red, second one yellow. What is the intersection of both? Here we are intersection of getting red and getting yellow. Now only these 6 events. Only these 6 events. First one red, second one yellow. First one, second one yellow. Here also first one red. Then this is Roman number 1. If you ask to encircle the areas, you have to draw around these all the 6 points and write question number 1. Then what is the probability?
6 over 36.
6 over 36. You write it in the simplest form. Now next one, both are red. Are red. Both are red here. In this one, these represent first one is red. Now here, second one is red. First red, second one red. Then both red means this area. Encircle the second one. This is second one. Both beads are red. Now here, red, red. When we take this point, first one red, second one also red. Both are red. Third question. Third one.
Both beads being the same color.
The same color.
Same color. Put here, all the beads are red. Then these, for this question, both are red. Same color. Here red. Okay, when we take this event, okay, this event, both beads are blue. Both beads are blue. In these 9 events, both beads are red. Here one, both are blue, same color. Okay, now look at these 4 events. Now in these 4 events, first beads are also yellow. In the second term taken also we get yellow color beads. Then both are yellow. So both beads are same colors. Both are red. Both beads are yellow. Both beads are blue. Both beads are yellow. Then how many beads are What is the probability of obtaining both beads are same color? 9. 9 plus 1, 10. 10 plus 4. How many? What is the probability?
14 over 36.
14 over 30.
14 over 36. Okay, next one. At least one blue. At least one blue. At least one bead is blue. At least අඩුම ගානේ එකක්වත් දෙකම blue උනත් කමන්නේ එකක්වත්. How many events are there? Now පුතා, in this line represent, these 6 points represent first bead is blue. Next one, from this line second bead is blue. Then at least one blue means this point. Now here in this point second one is blue. When we take this vertical line, first bead is blue. Then from this one represent both beads been, sorry, at least one is blue. At least one is blue. Then what is the probability? How many events are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many events are there?
11.
Then you can write the probability as 11 over 30, 11 by 36. The next question you ask, from this, now here we mark 4 events, 1, 2, 3, 4. What are the mutually exclusive events? What is meant by mutually exclusive event? Mutually exclusive? What is meant by mutually exclusive?
Disjoint. Intersection set is a null set.
Intersection is a null set. Then what are the events? The intersect vela nathiyawa balan. 1 and 2. Answers for the first question and second one. From this box and this one. These two are mutually exclusive events. Then intersection එකක් නැහැ නේද අපිට පේන්නේ.
Mutually exclusive.
Then these two are mutually exclusive. What are the other events? 1 and 2. What else?
1 and 3.
1 and 3. Same color. This one. 1 and 3 are mutually exclusive. What else?
2 and 3.
2 and 3. 3 ගන්න බෑ නේද පුතේ? 2 එකේ මේ දෙකේ intersection එකක් තියෙනවනේ මෙතන.
2 and 4.
Yes, 2 and 4. 2 and 4. 2 and 4 are mutually exclusive events, and 1 and 4 also mutually exclusive events.